Good evening, everyone. So I am Sonal and I welcome you all again in our evening session of Pulastya Science Festival. So in this session, what we are going to do is we are going to view the planets live from the night sky right now. So currently, there are three naked eye planets which every one of you can spot every evening. And these three bright planets we are going to see through telescope. So we have our team who are on upstairs actually setting up a telescope. So they are ready with a setup and they are eager to show us planets Mars, Jupiter, and Saturn. And I'm sure that you all are very curious to see how these planets look through a telescope. So let me ask my friends Atharva and Tushar to start sharing what they have.
Good evening, everyone. We welcome you all to the Skywatch from IUCAA, and we are very sad to do this online. We would have been very happy to have you all here and have you all have talking to you all live. But unfortunately, due to this COVID, we have to meet online. Nevertheless, we will be observing three objects today. The first object will be the planet Mars, or the red planet, and we are also going to see some features that are fairly visible in this video. So this is not really a video, believe me, this is a live view. So what we have done is we have set a camera to the telescope, and the telescope is observing planet Mars right now. So what we will do is let's try to see the telescope setup. So let me just start the video. Just a moment. I will stop sharing for a minute. Okay, I hope that you guys can see the video now. So this is the telescope setup. So I apologize for the movement. The camera is handheld. So now you can see this is the telescope setup. This is a Schmidt-Cassegrain telescope, and the red colored camera that you see is ZWO camera. So the name of the camera is ASI ZWO, and it is a CCD camera, and it is connected to the laptop using a USB cable. And this telescope is looking at planet Mars right now. I'm not sure if it is visible in the mobile screen, but nevertheless, let's switch back to the camera view now. So what you see in front of you is planet Mars, and you can notice that some regions on the Mars are darker than the rest of the regions, right? So those are the rocky features or valleys on the Mars. So the names of those features are, so as you can see my mouse cursor on the right hand side region. So that region is known as Valles Marineris. Okay, so it is a valley on the Mars. Then in the bottom, it is not very clearly visible right now because the image is a little bit wavy, but there is actually a polar ice cap. So similar to the Earth's North Pole and South Pole, even Mars has its own poles. And on one of its poles, there is an ice cap. Now, what is interesting about this ice cap is it is not made up of water. It is made up of solid carbon dioxide. So what we call as a dry ice. And just above the ice cap on the left region, this particular region where my mouse cursor is right now is known as Terra Sirenium. So now, while we are looking at this planet, there are a lot of scientific experiments and robots which are doing different science experiments on Mars. So now Mars is our neighboring planet, and we all know that there were missions like Curiosity, Spirit, Opportunity, and so many more orbiters. We had our very own orbiter, Mangalyaan, so which we were able to achieve successfully in the very first attempt. So that Mangalyaan is orbiting this planet. Then we have some rovers which are moving around the planet and doing some geology experiments and trying to find out if we can go and live there. So in the coming years, the humanity is going to attempt to set up camps on the moon, which will be our first frontier. And we hope that we will be able to move and colonize Mars, which will be the next frontier in the space exploration. So right now you must be seeing that the image is a little bit wavy. That is because of the wind that is coming and that is uh, hitting the telescopes. So there is a slight vibration, and you can also see that the image is not very crisp. That is because the Mars is not at a very high altitude right now, and there is some background noise in the sky as well. So where we are placed right now, there are a lot of buildings which have their lights on. So we hope that we will be able to produce a better image for Jupiter and Saturn now. So before we move on to the next planet, so I would like to mention that there are so many more missions which are planned for this planet here. And if one were to ask that, can we go and stay on planet Mars right away? So the answer is no. The reason is that this Mars atmosphere is not as dense as the atmosphere of the Earth, and there is also a lot of temperature variation on this planet. So for these reasons, and also it does not have the breathable oxygen and all the air composition that we need to survive. So for all these reasons, we cannot go and stay there right away. But we are trying to research: is there any way to harvest water? Is there any way to do some farming and agriculture? And if we are able to figure it out, we will soon be moving on to Mars. So before we move on to the next telescope, let me invite Sonal again. So she will tell us a little bit about the IUCAA uh, astronomy program, and she will also interact with you for a little bit.
Thank you, Atharva. So that was a wonderful view of Mars. And we can see Mars so much beautifully right now is because it's near to our Earth in the sky. So what happens is there are Mars, when Mars is coming closer, we can see it as bright as we can right now spot it. So if you go in your backyard on the terrace, what you will see is if you just turn towards the east, you will find a bright reddish object in the sky, and it it can be distinguished easily from other objects in the sky because it is really very bright and stunning, and that is our Mars. Then, as we go towards west, so we started from Mars in the east. As you go towards west, you will find two other bodies which are bright, but not bright enough, not bright like Mars. Those are the other two planets, the other two naked eye planets, which you can spot. One of them is Saturn, which is the dimmer one, comparatively dimmer one, and the brighter one is Jupiter. So we are going to observe Jupiter and then Saturn. How to um, differentiate between planets and stars, we'll learn later. But before that, I'll tell you a bit about programs we hold here at IUCAA. So, as Atharva mentioned earlier, we always like to have people around here in our campus to see the skies through telescope, as well as we like to get many questions also. So if you come across any question during the session, please post it on our live chat window. We'll be happy to answer them with, of course, it we have a limited time, but if we finish our live viewing of the planets, we may answer a few of those questions. So, throughout the year, IUCAA hosts different programs for public outreach where we host programs like sky watching, evening sky watching. Our Friday sky watching shows are famous. So many people in and around Pune generally visit us. And then there are other programs too. Apart from sky watching, we also have campus visits and basic astronomy workshops, science toys workshops going on throughout a year for school students as well as teachers and families. So there are different programs we host. You can find all these details on our website, scipop.iuca.in. So this was about IUCAA's programs. Now let us talk about the question I started with, how to differentiate between planets and stars. So you might have heard or read or observed that planets generally do not twinkle much. So if you compare the planets, right now, if you can go with your mobile in your backyard or terrace, you can actually see these three bright objects in the sky. Apart from these three bright objects, if you observe other bright things in the sky, you will observe that those other dots are twinkling. But these three bright objects, as I mentioned, the reddish one in the east, which is not twinkling much, is the Mars. Then towards the east, towards the west, there are two bright objects. One is yellowish, one is orangish. Orangish, one is Saturn, which is dimmer than Jupiter. So these are also not twinkling as the stars twinkle. So this is how visually we differentiate between planets and stars. And why do stars twinkle or why don't planets twinkle? So basically, we generally think about planets do not have their own light. Planets reflect sunlight, so they don't twinkle. And stars, like sun, they produce their own light, so they twinkle. So these are the answers we generally get. Okay, but the actual reason why planets do not twinkle or stars twinkle is because the Earth, or the very planet on which we are living, the only planet in our solar system that hosts life, has atmosphere. So the atmosphere is actually making stars twinkle. So there is no magical thing with stars producing light or planets reflecting starlight, but it happens due to the atmosphere. When the light of the stars are far away from us, and when their light comes to us, it gets disturbed by our atmosphere, the molecules, gas molecules, and dust particles in our atmosphere, and thus stars look like they are twinkling or shining. But what happens is, as compared to the stars, planets are much closer to us. And thus, if we set the telescope to planets, just like we saw on Mars, you can see a planet as a disk. But if we point our telescope towards any star, all we can see is the same tiny dot that is shining. Okay, so stars are comparatively much farther away from us, and that is why their light gets scattered a lot. While these planets are much closer to us since they are only in our solar system, in our neighborhood. So, comparative to stars, planets are much closer, and thus the light coming from them does not get scattered much. It, of course, gets scattered, but not to that amount to which the stars light scatter. And that is how we can differentiate visually planets from the stars. But the actual, if you are interested in spotting the positions of the stars and planets, the name planets or the word planets itself means wanderers. Wanderers. So wanderers are those who visit or those who are not steady in the sky. So they like to travel. Okay. So if you observe these planets and stars follow same patterns. Like if you observe currently, Saturn and Jupiter are in a constellation called as Sagittarius. Mars is right now in constellation called Pisces. But after a few months, you will find that these planets have traveled forward and they are at different positions as compared to the stars. While the Pisces stars will look like the same, will show us same formation, and Sagittarius stars will also show us the same formation. But planets can be seen moving across the sky. And that is why the name came as planets. So I'm sorry, let me just check that if my friends are ready with Jupiter.
Sonal, we are ready now.
Yes.
We will start the
Okay.
screen sharing.
Great. So
Just
let me mute myself as Atharva and Tushar are ready with our next planet in the list. That is the closest, biggest planet. Sorry, there's the biggest planet in our solar system, Jupiter.
so this is the planet Jupiter. So this planet is also popularly called as a gas giant. So now, had this planet been a little bit bigger, it would have turned into a star. So Jupiter is often referred to as a failed star. Uh, it's not too bad that it did not become a star. Jupiter is also responsible for saving us from a lot of accidents. So Jupiter is so massive that whenever any asteroid or any big comet, uh, tends to come near the Earth, towards the Earth, most of the times it happens that Jupiter pulls the comet or the asteroid towards it and clears it out of Earth's orbit. So this we are very lucky to have Jupiter in our solar system. Uh, in the image now, I will make some changes, and you will be able to see some bands on Jupiter. So there are these horizontal lines that appear, and there is a small bulge over here. So if you keep looking at the image as it becomes stable, you will be able to see a small bulge. So that will be the great red spot on the Jupiter. And so great red spot is basically a storm which is visible on Jupiter for hundreds or thousands of years now. Now, it may appear as a very small dot in this image, but this great red spot is at least 3 times bigger than the size of the Earth itself. So now you all know that the Earth's diameter is roughly around 6,400 kilometers. So, sorry, the radius of the Earth is 6,400 kilometers. So now if you compare the size of the Earth and multiply it by 3 times, that is the size of the great red spot. Now, apart from Jupiter, there are two small objects on the left hand side. So I will increase the brightness so that those faint objects appear. So now the Jupiter details are not visible very clearly, but you can see two more objects here. Just a second. Okay, so these two objects are basically the moons of the Jupiter. So Jupiter is unlike Earth. Jupiter has many moons. So Jupiter has more than 67 recorded moons, and the number varies depending upon the orbit of the Jupiter. And the reason why Jupiter has so many number of moons is because there is a large asteroid belt in between Mars and Jupiter. So there are if you see the solar system starts with the sun, and the first 4 planets are the terrestrial or the rocky planets. And Jupiter and onwards, all the planets are known as the gas giants. So the two moons that you see are the names of those moons is Io and Europa. So the one closer to the Jupiter is Europa. The one slightly farther away is Io. Okay. We will see if we can see another one. So there is a third. Yeah, there it is. So the one in the left bottom corner is Ganymede. So Ganymede is the largest moon of Jupiter. So those who are on the phones, please set your phone brightness to the maximum to get the best view. So you can see in sequence from right to left, there is Jupiter, then there is Europa, then there is Io, and then there is Ganymede. So these moons were first observed by Galileo using his own telescope. Hence, they are known as Galilean moons. So we will switch back to the Jupiter. We will reduce the exposure. We will see if we can see the fourth moon, if it is there in the field of view. I will just zoom out a little bit. Yes, it is visible actually. In the Sonal, can you give me a feedback if this moon is visible, because it is very faint? I will increase the exposure. Okay, so now you must be able to see this moon. So this is the fourth moon, which is Callisto. So we were able to see all the four Galilean moons, the moons that Galileo first discovered, and that created a revolution. Because before that, we all used to believe that Earth is at the center of our solar system, and everything used to revolve around Earth. And when Galileo saw this view from his telescope, he was shocked, and he was rather uh, terrified that, well, the Earth is not at the center of our solar system, and then there is something like Earth in the sky, which is Jupiter, and it has its own moons revolving around it. So let's revisit the moons again. So the top right one is Callisto. Then we have planet Jupiter in the center. Then we have Europa. Then we have Io, and this one is Ganymede. So Ganymede is the largest moon of Jupiter, and it also is the largest moon in the solar system. Okay, so we can see all the four Galilean moons, and we can also see planet Jupiter. So let's look at Jupiter one more time, and then we will move on to the last object of this evening. So I will reduce the brightness a little bit. Let's take a look at planet Jupiter once again. So actually, you can see many bands on Jupiter, kind of like a cricket ball, the seams of a cricket ball. So those bands are a result of the weather. There are different gases which are there on planet Jupiter, and the different gases have different densities, and they have different compositions, which gives different colors to those bands. And Jupiter's bands are not static. So and another exciting thing about Jupiter is, so if Jupiter is at opposition, you can see almost entire Jupiter all over the night, because the revolution period of the rotation period of planet Jupiter is just 11 hours. So if Jupiter is at opposition, meaning as soon as the sun sets, if the Jupiter is rising on the eastern horizon, all over the night, you will be able to see almost entire Jupiter in a single night. The reason is the rotation period of Jupiter is just 11 hours. So if you keep observing the image, sometimes the image gets stable, and that stable image is called as a lucky image or a lucky frame. And in that, we are able to spot the features of Jupiter, and we can see the bands of Jupiter, the great red spot, and we also saw the Galilean moons. So once again, I am going to hand over to Sonal while I move on to the next object. I will stop the screen sharing.
Thank you, Atharva. So again, Jupiter was looking wonderful. And there are a few questions I would like to address those questions before going to Saturn. So first question I would like to answer is someone has asked that why is the image and video not clear? So basically what we do is when we use a telescope, we are kind of, we are actually magnifying the object. Okay, so Jupiter can be seen with naked eye just as a spot, a bright spot in the sky. But when we magnify it using lenses, a combination of lenses, at that time we are magnifying the light coming from that object. And since Earth has an atmosphere, there is a turbulence. And when we magnify the object, that gets magnified too. So the image may look a bit blurry and not so sharp because of the turbulence. And as the objects are getting closer to the horizon, this turbulence gets increased. So near horizon, the planets look more turbulent kind of. So this is the type of image we get when planets arrive towards the horizon. This is totally due to atmospheric turbulence. So there are other questions I would like to answer. So okay, about someone has asked that can't we zoom in more? So what we have done is we have put a camera there. So maybe Atharva can tell us details about the camera, how many times it is magnifying the actual image of the Jupiter or actual image of the planet. But basically, the magnification depends on the focal length of the eyepiece we use as well as the telescope. So, in mathematically speaking, the ratio of the focal length of telescope and the focal length of eyepiece gives us the magnification, how many times the image gets magnified. So I'll request Atharva to tell us more details about this. How many times currently we are magnifying the objects, as well as someone has asked what is the price of this telescope. So maybe Atharva can answer these questions later after we have viewed the Saturn. So let us get back to those questions later. Uh, so there are a few other questions like why is it visible only for today? So it's an interesting question, Vinita. So these planets are currently visible in the sky from actually from past few months. So it depends on the speed of the planet or revolution period of the planet. Okay, so uh, the Mars is actually going to be visible to us until mid June next year. Okay, so Mars will be visible for about next 8 months in the sky, and after that it will go below horizon. So it won't be visible in our night sky. Jupiter and Saturn, though, as you can see, they are already approaching our the sky near western horizon. So these will be visible till mid December only. So this is no any special day, but it's only special because Mars is currently in such a position with respect to us, I mean the Earth and the Sun, so that it is appearing more bright, it is more closer to us. Now, what happens? Let me explain one concept over here. So, if you have anything, so currently I have a book with me. Okay. So, if you hold it closer, you can see that it looks much bigger, right? So, the angle this book is making with your eye is more. But as you take the book away, all you can see the size of the book is getting smaller. Okay, so actual book is having the same length, but it is moving away, and thus it appears smaller. So the angular size of the book, the angle it makes with our eyes, is is decreasing because just we are moving away or the object is moving away from it. So this particular term is called as angular size. Right now, Mars in such a position with us, it is near to the Earth, and thus we can see it much bright. It is actually outshining Jupiter, which is generally the brightest planet after Venus in the sky. So this is why we are observing it today. But apart from that, if you haven't attended our day sessions, we are celebrating a science festival at IUCAA, which is Pulastya Science Festival. And this festival is on the occasion of our beloved Pula Deshpande's birth anniversary, which is tomorrow, that is 8th November. So, and today marks the death anniversary of Sunita Bai Deshpande, Pula's wife. And this couple was uh, in this public outreach. public outreach work. So that is why every year we celebrate Pulastya Science Festival on the occasion of Pula's birth anniversary. And that is the occasion we are doing it today. And apart from that, today also marks as the birth anniversaries of India's first Nobel laureate in physics, that is C.V. Raman, as well as birth anniversary of Marie Curie. So this is kind of a wonderful day, and thus we are observing it today. Otherwise, throughout a year, as I earlier mentioned, we host live skywatching stations where people can themselves come and visit us and look through a telescope and get known or introduced to different such objects in the sky, how to identify constellations, how to identify different planets and stars. But currently, due to this unfortunate COVID situation worldwide, we have to conduct this program online. And in a way, it is beneficial because when we have live, means when people come here, it generally becomes limited to the close by people, people who live near Pune. So right now, I'm sure that many of you are outside Pune and watching this program. So yes, so that's why we are doing it live right now. There is one question which I would like to answer before going to the live session again. So there is one question on, are there any telescope workshops? So yes, we host telescope making workshops throughout a year. In fact, person who is actually handling right now telescope with Atharva, Tushar, he conducts telescope making workshops throughout a year all over India. So in IUCAA, we have a telescope making laboratory where we guide people. People come here and we guide them, and they can make their own telescope. So you can grind your own mirrors by your own hands and make your own telescope. So there are such workshops we host. You can find all the details on our website again, as I mentioned earlier, it's ipop.iuca.in. So the website link you will find in the description. So I think if let me check with Atharva if they are ready with the next planet, Saturn.
Yes. Hi, Sonal. So we are
Thank you.
ready. Before we move on to the next planet, which is Saturn, let me just give a little bit uh, introduction of the planet. So, planet Saturn is also a gaseous planet. Let me just start the screen sharing quickly. I hope it is visible. Okay. So we are going to change the exposure and everything a little bit to highlight more details. So you must be able to see the planet in the center, and the planet is surrounded by the rings, and the rings are slightly tilted in orientation, right? So now when looking from the Earth, this orientation keeps on changing. Uh, there is a time period over which these rings change orientation, and sometimes the rings come in the plane of the line of sight. So it almost appears as if the Saturn's rings have disappeared, because the rings are so thin that we cannot visually determine the thickness and visually observe the thickness of the rings. So during some points in the Saturn's orbit, when observing from the Earth, we see that the orientation of the rings is in line of our side. So if you are able to see my mouse cursor, you can see that this is the ring, and there is a small gap in between these rings. Okay, so actually there are almost 7 rings which are layered in series, and those rings are, oh, the video, just a second, let me restart the video. Just give me 1 second. Yeah. Sonal, just can you confirm if the image is clear?
Yes, Atharva, I'm checking it. So it is not yet that clear.
Okay, so we will just try to focus it even a little bit.
Yes, yes, sure.
Okay, so there is a planet in the center, and then there are actually 7 rings around it. And between the fifth and fourth and the fifth ring, there is a small gap. That gap is called as the Cassini division. Okay, so the name Cassini is given after the scientist, and the spacecraft which had traveled to capture the uh, photographs of this planet was the probe was named as Cassini-Huygens. So it is named after it. We will also be able to see one of the moons of the Saturn, which is Titan. So actually, the Titan is very faint. So we will have to overexpose the image. So we will have to increase the exposure. So the details of the Saturn will be overexposed, but you will be able to see a small object here near my cursor. Okay. So this object or this bright dot that you see is one of the moons of Saturn. So similar to Jupiter, even Saturn has a lot of moons. So this moon right here is called as Titan, and it is an interesting uh, object in our solar system. The reason is that it contains liquid methane. Okay, so just the way the Earth contains liquid water, and we are in what is known as the Goldilocks zone, this moon, Titan, contains lakes of liquid methane. So it is a very interesting place, and scientists are very curious about how the structure of that moon is, and can any microbial life grow there. So we all require water, and we all require oxygen and nitrogen and all the air to survive, but there are some anaerobic microbes which do not require air to grow. So there is a possibility that there might be a life form or different microorganisms growing there. And if there is so, then we will soon be able to say that there is life on other planets too. So Titan is always an object of interest, and there have been missions in the past who have studied the moon Titan, but there will be more missions which will be doing some further better experiments. So now you must be seeing that the object that is the Saturn is scintillating. That is because the sky conditions are not very good. The Saturn is at a lower altitude right now, but some time in between you will be able to see the rings of the Saturn. I will just try to zoom in a little. Sorry, focus it a little bit. It's not improving too well. Okay, let's continue with the same focusing. What you will see is that there is a planet, there is a gap in between the rings, and there is a even finer gap in between one of the rings. So that gap, as we discussed, is called as the Cassini division. So just like Jupiter, there are around more than 67 moons for this planet also. And some of the interesting moons are Titan, then there is Enceladus. All these moons are interesting. Enceladus is interesting because it has a thick ice covering on it, and below that there may be some liquid water. And whenever the moon revolves around the Saturn, so these water jets spray out of the moon surface, and it's a beautiful sight to see. So this is another interesting planet. What is interesting about this planet also is the density of the planet is very low. So the density is less than that of water. So if we are able to build a very, very big pool, much larger than the planet Saturn, and if you drop Saturn in it, planet Saturn will float on it because the density is much more less than compared to the water. So that is another interesting fact. So having said that, I will again hand over to Sonal, and I will until then try to improve the image quality of this again. So I think Tushar sir will tell us about the telescope project and also. So over to you guys.
Thank you, Atharva. And that was a wonderful view of Saturn. And actually, we got a question that is it a real image or are we showing you a graphic? So no, friends, we are showing you the live planets and all those things. Actually, we get such questions in live skywatch also that when people look through telescope at me, they always ask, "So have you put any picture in front of it?" So no, it was a live show. So we have shown you live planets, and these three planets are visible naked eye right now. I'll repeat once again. Currently, if you go to your backyard, right now around your zenith somewhere, you'll find a reddish bright object that is planet Mars. Then, as you look at the western horizon, you'll find two bright objects. The brighter one of them is Jupiter, which is towards horizon, and there is another dimmer object, which is again another planet that is Saturn, which we just looked through a telescope. So, after seeing these planets with naked eyes, you will find what is the importance of telescope or why telescope is needed. So yes, right now Atharva has just shared a screen. You can see how beautiful Saturn looks. So I guess with that, I'll stop talking, and we have Tushar with us, who conducts telescope making workshops. So he will be telling us more about telescopes, and with that, we'll then end our session. So Tushar.
Yeah, hello everyone. Basically, when we are talking about a telescope making thing, you can always welcome to IUCAA and make your own telescope. There is not necessary that how much diameter you have to make. That depends on you. And keep watching regularly the IUCAA website, IUCAA telescope making. So on IUCAA website, we have put one registration form for enrolling your name for telescope making activity. It's a regular activity, and you can also come down and grind and polish and make your own telescope with your own hands. So that is a regular activity. You can come down anytime. And right now we are showing the most of the beautiful these objects with the telescope. So that telescope is a go-to type telescope. It's basically the motorized and computerized telescope. So easily we can operate the telescope. Along with this telescope, we have kept a CCD camera. So with the help of this camera, we are capturing the images. So whatever generally what we do, we can take the video of that particular images and stack all the images one over one. And we can get a very beautiful image of the Saturn or Jupiter. But because of the slightly haze in the sky and slightly air turbulence, the image is not quite sharp. But we have tried our level best to show you the best of the images, and particularly you can enjoy this. So keep a touch with us, and you can come down and make your own telescope.
So thank you, Tushar. With this remark, visit us. Stay tuned to IUCAA SciPop, where you'll find all the details. We have our Facebook page, Twitter account. You can follow these social media handles. You can keep checking with our website. And of course, you can like, subscribe our channel, YouTube channel, where you will be finding very interesting sessions. Those go online. So thank you very much. We'll sign off now, and at the end I'd like to thank the team of IUCAA, so who are not in front of the camera right now. Like Atharva is upstairs with the setup, and Ishan is there handling our live streaming. So thank you very much. Thank you. Stay tuned.